Hello. Yeah, hi everyone. Welcome to the webinar. So I'm Pooja and today I'll be the host and your mathematics tutor at LearnPick. So the topic for today we have is triangles. So let's get started. Now I'll just start with the Okay, so the topic we have is triangles. Now, I know that a lot of you love pizza and nachos and like a lot of things which are like sandwiches, which are kind of triangles and all this stuff. So, the triangles is kind of similar to those shapes I can tell about, not those tastes. Okay, so let's talk about triangle in this. So, in this session, we'll be considering three parts of it. So the hashtag one is what is similarity. Okay. Then hashtag two is what is similar polygons and triangles. And in the third part, that is hashtag three, will be talking about areas of similar triangles. Okay. Before getting into hashtag one, two, and three, I'll give you a quick recap and a bit information about triangles and the recap about the ninth standard which you've already studied. So let's get into the first part, that is a types of triangle. Now, before getting into types of triangle, I tell you what does exactly a triangle mean. Okay, so a triangle is a figure which has three sides and three angles. Now, why does it have triangles name? Because tri means three and it will be having three angles. Therefore, it is considered to be a triangle. Okay, so let's get into what are types of triangles. Now, types of triangle is classified according to two parts. The first part is considered to be on the basis of by angle. Now, what does that mean? That according to the angle of the given triangles, we can classify the triangles. The first we have is equiangular. Now, what does that mean? Equiangular means that all the angles of the triangle will be equal. Okay, so all angles are congruent, that is equiangular. Acute means that one like all of the angles will be acute angle. Now, what does acute angle mean? Acute angle means less than 90 degrees. Okay, so all the angles will be less than 90 degrees. Right angle triangle. Now, one angle will be right angle, that is 90 degrees. Okay, so not all of them can be 90 degrees because we know that sum of all angles of a triangle is 180 degrees. So only one of the angles of the right angle triangle will be 90 degrees. Okay, the next we have is obtuse angle triangle. Okay, or what is obtuse angle triangle? One of the angle will be obtuse angle. Now before that, what is an obtuse angle? Obtuse angle means an angle which is more than 90 degree. An angle which is more than 90 degree is an obtuse angle triangle. Okay, now this were on the basis of angle. Now let's talk about on the basis of side. Okay, so on the basis of side, the triangles are categorized into three parts. First is equilateral triangle. Okay, equilateral triangle, we all know that all the sides will be congruent. Okay, next we have is isosceles triangle. So what is isosceles triangle? Isosceles triangle means only two sides will be congruent. Next we have the scalene triangle. Scalene triangle means none of the sides will be same or they will be congruent. I hope you're clear with what are types of triangle. Now let's get into the next part, that is hashtag one. I hope you're clear with what are triangles and the types of triangles. Now we have hashtag one, that is what I won't tell you now. Okay, let's take a quick recap of the part of the ninth standard, that is congruency. Now, what does congruency mean? Congruency means figures having same shape and same size. If we talk about a pair of chappals, so like the size is shape same, and the size the shape is same and the size is also same. So both the chappals are considered to be congruent. Okay, I'll give you one more example on the basis of mathematics, that is two triangles. Okay, so if you talk about triangle ABC and triangle DEF, both of them are congruent. So how can we tell that both of them are congruent? Just by that, you can see that these lines are present to indicate that both of these sides are same. This side and this side is same. Again, this and this side is same. Okay, if you talk about AB is congruent to D, AC is congruent to DF, and FE is congruent to CB. Okay, all these sides are congruent, and if we talk about the angles, angles are also congruent. So same shape, same size are considered to be congruent. Now we have something, a property in which we have same shape, but we don't have a same size. Now what does that mean? What is this property called? This is called as similarity. That means that whatever girls will be talking about, they will be having same shape. If you talk about two triangles, so they'll be looking same, but the size will not be same. Okay, if we have a pair of chappals, I think there was some Okay, so let's get back into this. So what is this property called? This property is considered to be similarity. Now, what does the similarity mean? So inside this too, similarity is, what is similarity? Two figures having the same shape and not necessarily the same size. Now, what does that mean? That two butterflies, okay, so you can see this figure that these two butterflies have same shape, but don't have same size. Like if I talk about a pair of chappals, and in which is of one of the chappal is of 8 size and other one is of 6 size, that means that both of the chappals have the same shape, but they don't have the same size, and then they are considered to be similar. Okay, they are not considered to be congruent. Getting my point? What is similarity? Two figures having the same shape, but not necessarily the same size, are called as similar figures. Okay, so, like if you see these examples, now we have puppies in this image. So, like you can see that both of these puppies, they look very same, but they have same shape, but they don't have same size. That means the one on the right is like one is the bigger one and the other is smaller one. That means the shape is same, but the size is not same. Then these are called as similar figures. Let's look out for some more examples. Tell me, are these two considered to be similar? Do answer this question. Tell me, are these similar or not? Both of these. No, they are not similar. Now, if you can see that both of them are wearing the same t-shirt, but both of them they are also wearing the same color, right? But both of them are totally different in shape. Like one is a human and the other is dog. So the shape is totally different, and this shape is not different. This is not. They are not. Jump into the next one. So if we talk about these trees, you can see that shape is totally the same. But if you talk about the size, they are totally different. So if the size is different and the shape is same, they are similar figures. So this is a similar figure. One more example. Are these triangles similar or not? They are not similar. Okay, why they are not similar? You might have observed that they look like they both are triangles, right? But triangles also have some criteria. According to that, we can say that they are similar or not. So that will be studying in the next part. Okay, so they are not similar because you can see that the shape is totally different. So you cannot consider them to be similar figures. Okay. So this was the hashtag one part, that what is similarity. So what is similarity? Figures with same shape but different size. Okay, they can be different size. Okay, they are considered to be similar figures. Okay, so we have hashtag two now. Now what is hashtag two? Hashtag two considers similar polygons. Now what does polygons mean? Polygons are plane figures with infinite number of straight lines. Okay, it can be one line, it can be two lines, it can be angle, it can be triangle, it can be quadrilateral, hexagon, pentagon. All these are considered to be polygons. Okay, so first let's understand according to the polygons what are similar polygons, and then we'll be clear that what are similar triangles. Okay, so two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are in the same proportion or same ratio. Okay, now what does that mean? I'll explain you this part example. So two polygons. Let us consider two polygons to be quadrilateral. Okay, now two polygons have same number of sides. So same, now we cannot take a triangle and a quadrilateral. They clearly mean that the number of sides should be same. Three, this side four, then four. Okay, so let's talk about quadrilateral. Quadrilaterals have four sides, right? So if we take two polygons, they should have same number of sides. Now, first point tells us that their corresponding angles are equal. That means that one of the angle of both polygons should be equal. Okay, and their corresponding sides are in the same ratio. I'll explain this with this example. Okay, so we have triangle, so we have quadrilateral ABCD, and we have quadrilateral A dash, B dash, C dash, and D dash. Okay, now you can see that angle A, so you can see that angle A is equal to angle A dash. That means that both of these angles are equal. So when both of have equal measurement, they are considered to be corresponding. Okay, you can see that angle B is congruent to, like, it's equal to angle B dash. If you see angle C, it's equal, or you can also consider it to be congruent, because congruence means equal measurement. Okay, so angle C is equal to angle C dash, and angle D is equal to angle D dash. Now, this was the first point according to the explanation that how we can prove they are similar. I'll just repeat the first part. Their corresponding angles are one of the angles of both polygons should be equal. So in both in this case, we have angle A and A dash, B and B dash, C and C dash, and D and B dash. This was the first point. Now, second, their corresponding sides are in the same ratio. Ratio means like if you take 2 by 4, so if you simplify it, what is it? It is 1 by 2. So that is considered to be a ratio. That means that whatever ratio you get, okay, so if you talk about AB and A dash B dash, what is the value of AB? 5, right? And what is the value of A dash B dash? It's 10. Okay. So if you simplify it, what is the ratio that you get? You get it as 1 by 2. Correct. Now, if you talk about the next one, that is BC and B dash C dash, what is the ratio you get? 1 by 2 again. If you talk about CD and C dash D dash, 3 by 6, again 1 by 2. If you talk about AD and A dash B dash, what is 1 by 2 again? So you can see that ratio are in proportion. Proportion means they are all equal. Okay, then if angles are equal and the sides are in proportion, the sides measurement should not necessarily be equal, but the sides ratio should be same, then those are considered to be similar polygons. Okay, I hope you are clear with this part. What are similar polygons? So in like I'll tell you this part now. What A corresponds to? A corresponds to A dash. You can see that angle A, that angle A Angle A corresponds to angle A dash. That means both of these are equal. If you see that angle B corresponds to B dash, both of these are equal. C corresponds to C dash and D corresponds to D dash. Okay, this is what is explained in the third point, that correspond. Correspond means both of them of equal measure. Okay, let's get into the next part, that is some questions on it. Okay, so you are clear about what are polygons. So they have corresponding angles equal, and the angle and the other, like this two angles are corresponding, they should have equal. Okay, and the sides should be in same ratio. Okay, so let's have some questions. So fill in the blanks using the correct word given in the bracket. So you've already given the options and you just have to answer the questions. All circles are dashed. Now, if you talk about a ball and a clock, okay, just the circle part of it. So they are of the circle, like they are in the shape of a circle, correct? But are they congruent or are they similar? I'll just repeat what is congruent and what is similar. Congruent is totally equal, same shape, same size. Similar, only same shape, but not same size. If you talk about a ball and clock, the circles of both of those, what are they? They look what? Their shape is same, right? But their size is not same. Therefore, the answer is all circles are similar. Okay, let's get to the next question. All squares are dash. Again, the same thing. What it will be? It is again similar because two squares, like any two squares randomly, if you imagine, then they cannot be congruent. All out with all, like so many of squares, they are not congruent, right? But all of them squares look like squares, right? They are similar, they are in shape, but they are not congruent. Okay. Next we have is dash triangles are similar. That means all triangles, which triangles can be similar? All equilateral triangles are similar. Okay, because all of those sides are same. So what if you talk about or like all the like if you talk about any random equilateral triangles, so they all look similar. Okay, but if you talk about an isosceles triangle, they cannot be. Equilateral triangle has all angles extremely correct. So if you talk about isosceles triangle, they can be totally different. Okay, one can be right angle triangle and the other can be a scalene triangle, right? So they cannot be similar. Their shape cannot always be similar, right? Getting my point? So the answer is this is the point we just studied. The two polygons of the same number of sides are similar if their corresponding angles are. What is the answer? Angles should be what? They should be equal. And the sides in proportional. Right? So what we studied in the previous part, that is what are similar polygons. So what are similar polygons? Polygons having same number of sides. So if you talk about a rectangle, a square, a triangle, hexagon, pentagon, any of the polygons, they should have same number of sides. Okay. After that, the first point is angles should be equal. If you talk about triangles, two triangles, the angles should be totally equal. And the sides should be in proportion. So which I've already told you the example of that. Okay, let's get into some more questions. So give two different examples of pair of non-similar figures. So what we studied about similar figures that the shape should be totally same. So if you talk about two cakes, okay, so one is of the shape of a circle and the other is the shape of a heart. Are they similar? No, they are not similar, correct? Because the shape is totally different, so they cannot be considered to be similar. So let's have two examples. Now these can be any random examples, okay? So the examples I've taken is rhombus and rectangle. They look similar, right? Because the shape is totally different. Triangle and square, again, they are totally different, correct? Okay, let's get into the next question. So the question we have here is state whether the following quadrilaterals are similar or not. Okay, I want you guys to answer to this question. I'll just put the question and let me know what is the answer to this question. So one we have a quadrilateral with that's PQRS and the other quadrilateral is ABCD. So the first quadrilateral has the measurement as 1.5 centimeter and the second quadrilateral like on all sides and the second quadrilateral you can see that it has 3 centimeter on all sides. Now if you clearly see for both the quadrilaterals, the measurement for the first one has all sides equal and for the second one has the all sides equal. So tell me, are they similar or not? I just want you guys to answer yes or no. Okay, let's check it. So the answer is they are not similar because the shape is totally different. So even if you can see that the measurement for the first quadrilateral for all the sides is same, and for the second quadrilateral also the all the four sides are same, but the two of these quadrilaterals are totally different in shape. Since they are totally different in shape, they are not similar figures. Okay, so we get these type of questions and they can ask you are they similar or not. So but just to the main thing which you have to remember is the shape should be same. And if the shape is not same, you should not go for the next part, that is, are they similar or not. Okay, so if the shape is same, they are similar. If not, they are not similar. Okay, let's talk about similar triangles. So we are clear with what are similar polygons. Okay, polygons, it can be any type of a polygon. It can be a angle, triangle, quadrilateral, any of those. But our topic is about triangles. So basically, we will be about similar triangles now. Okay, so what are similar triangles? Two triangles are similar if their corresponding angles are equal. Same thing which was which we had with polygons, but the difference is that they were polygons and these are triangles. That's it, nothing much the difference out of both of those. Okay, so the first one is the triangles have angles equal and their corresponding sides are in same proportion. Okay, so we have an example to this. So we have triangle ABC and we have triangle DEF. So if you carefully observe both of these, if you carefully observe both of these, angle A, what is the measurement of angle A? 65 degree. What is the angle measurement of angle D? 65 again. Okay, if you talk about angle C, what is the measurement of angle C? 40 degree. What is the measurement of angle F? 40 degree. So two of the angles we have already got as same. Angle B, 75 degree. Angle E, 75 degree. So from this, it's clear that the angles are congruent. That means the first part is already what? Clear, right? The first part is already clear that angles are equal. So we can say both of these are triangles are similar. Let's look out for the second one. So second point says that the sides are in same ratio. So let's check if if you take 5, 1 by 6 by 2, okay. 1 by 2, 1 by 2. See, if from both, it is very clear that even the second thing is satisfied, that is, both of these triangles are what? They are similar. Okay, both of these triangles are what? They are similar. So similar triangles are the exact same shape but are different sizes. So you can see that both of these triangles are what? Both of these triangles are same shape. Okay, both of these are triangles and they have equal angles as well and sides in proportion, but they have different sizes. DEF is quite smaller if you compare it to triangle ABC, right? So therefore, triangle ABC, so therefore, triangle ABC is similar to triangle DEF. Now, this symbol, what does this symbol mean? This symbol is specifically denotes that they are similar. So whenever we have to we have to notify, like we have to show that the given triangles are similar, we put this similar sign between the triangles. Like we put for congruent, so what does this congruent sign is like that, right? So the equal to sign means that the all the angles and sides are equal, and this side means that they are similar as well. So in similar, we don't put the equal to sign because they are not equal in measurement. Okay, this is the sign for showing similarity between the triangles. Okay. So two triangles are similar if their corresponding angles are equal and their corresponding sides are in the proportion. Okay. So let's get into the criteria for similar triangles. Now, what is criteria for similar triangles? Like if you talk about any party, okay, theme party. So if you talk about any theme party, they have some criteria. Theme party means there will be some theme. Now it can be Halloween. So what does a Halloween party mean? That you all have to get dressed like Halloweens, correct? So same, no, like similar to that, we have criteria for similar triangles. Now what is criteria for similar triangles? That whenever we have triangles, how can we prove that those given triangles are similar or not? Okay, so these are the three criteria for similarity of triangles. Now, these are also called as tests of similarity because, like, as you have, like, whenever you have exams, so why do you give your test? So, it like the school or the teachers gets to know that how much you've studied and how much you know. That is the test for. So same, this test is to clarify that are the triangles similar or not. Okay. So the first test is AAA test. Now what does that mean? Angle test. Okay. So corresponding angles should have equal measurement. Okay. So triangles, if there are two triangles and they have equal angles, then the corresponding sides are in proportion. Okay, and those triangles are considered to be similar triangles. This is called as AA test. So if there is any two triangles in which we can see that the angles, like three of the angles are of equal measurement. So on AAA test, you can say that the given triangles are similar. Now this is also called as AA test. Why AA test? Because if two angles are congruent, obviously the third one is going to be congruent because we know that the total is 180 degree. So whatever remaining will be the third angle for both of the triangles, that will be same. So it can also be called as AA test or AA test. That is angle or angle test. Okay. So what is the main thing you have to remember? Angles. If the angles are equal, the corresponding sides will be in ratio and the triangles are similar. Let's look out for the next one. Side test. Now what is this? Sides, if the sides are in ratio, that is the same ratio, the angles will be equal. Okay, like in the previous one, the angles were what? They were equal. Then the sides are in ratio. Now here it is opposite. Okay, now here it is what? If the sides are in same ratio, the angles will be equal. Then the triangles are said to be similar triangles. Okay. So let's look out for the third one. So what is that? That is SAS test. Okay, now what does SAS test mean? Now SAS test means side test. Now that means that one corresponding angle is equal. Like if you have two triangles, the if we talk about these two triangles, so if only angle A and angle D is congruent, and like if both of the rest two are not congruent, okay, and the sides are in ratio, okay, one corresponding angle is equal, so A and D are equal, and side including the angles are in proportion. Now, if this side and this side of both of these triangles, if they are in proportion, so the angle should exactly be in between these two sides. Okay, so you can see that angle A and angle D is exactly in between these two sides. Like if you talk about if this this is not done. This property, like this test, does not prove that these triangles are similar because this angle is not between two sides. The angle should be exactly in between the two sides which are in proportion. Okay, so what was AA test? Angle test. That means that if three angles or all of the two angles are congruent or equal, then the sides will be in proportion and the triangle considered to be a similar triangles. Okay, if we talk about SSS test, what was SSS test? It was side test. That means that if all the three sides are in proportion, then the angles will be congruent, and if the angles are also congruent, the triangles are similar. What are the third one? Side test. So one like a side, then an angle, and then a side. So if the one of the angle is equal and the sides including that angle are in proportion, then the triangles are similar. Okay, I hope you're clear with what is criteria for similar triangles. Do anyone have any questions they can ask me? Do let me know whenever you have your questions, okay? I'll just continue with this part. So we are clear with criteria for similar triangles. Now let's move towards the next part, that is some questions. Okay, okay, let's move to some questions now regarding criteria. So the first question is, are the similar is which criteria of similarity of triangles? So it can be AA test or AA, or it can be SSS test, or it can be SAS test. Now let's see if which of the criteria can be used over here. So you can see that two sides are given. So you can see that two sides are given, and what are the angles given. Okay, so and you can see that both of the angles are 80 degrees. But if you clearly observe to the both of the triangles, what is happening? In, you can see that the sides are 2.5 and 3. So you have 5 and to take both of these triangles, what is happening? So in triangle ABC, you can see that angle A is 80 degrees and angle A is not exactly in between the two sides. Right? If you talk about DFE, the sides have the angle exactly in between them. So let's see, are they similar or not? Two triangles are not similar as a given pair of equal angle is not included in the difference. Okay, so in essay, this could have been proved if the angle B was 80 degrees. Then we can prove it that by SAS tells that both these given triangles are what? They are similar. But angle is not in between, right? So these two triangles are not similar. Done. Let's go to the second example. So second example we have, are the given triangles similar? If yes, then by some criteria of similarity. So let's check. We have triangle DEF, we have triangle PQR. Okay. Now, in triangle DEF and PQR, you observe angle D is what? 70 degree. Angle D is equal to angle P. Each is 90 degree. Now, how could each is 90 degree? Because you can observe in this part, you can observe in this part that this is 80 degree, right? And, and we have already given that these two angles are what? Equal. So this will be what? This will be 30. So what is remaining in both the triangles? 70, 70. Both of the triangles will be what? Like both of the angles will be what? 70 degree. Let's go for the next one. Now angle D is equal to angle P because each is 90 degree. Now let's look out for angle E and angle Q. They are also equal. Why? Because each is 80 degree. Now, if you observe carefully, we can also prove these triangles as similar by A. We have two triangles as equal and they can be done over here itself, right? So they can be similar by yes, done. Okay, so only two steps and you'll be done in this part. So whenever you have to prove the criteria for similarity of triangles, what you have to observe first is like first you have to observe the angles, if the angles are congruent or not. Or two, then you have to observe that are the sides are in proportion, and then you have to observe that if sides or one of the angles is equal, you have to check by all of these three criteria. So which goes with them and through that criteria you can prove that the given triangles are what? They are similar. Okay. So these two triangles, triangle PEF and triangle PQR, is similar by criterion of similarity. Okay. Now let's go to the next example. Okay, so now here we don't have any angle in this part. That means this is going to be quite thing for us to solve. Okay, so in this part, what you have is triangle ABC, and the side AB is 2, side BC is 2.5, side AC is 3, PQ is 6, QR is 4, and PR is 5. So let's look out for the solution of this question. Are they similar or not? So if in triangle ABC, you can see that the smallest side of triangle ABC is what? AB. Smallest side of triangle PQR is what? QR, right? So AB, BQR. Okay, so what we are doing first is all the sides which are in proportion, like all the sides first, and then check are they in proportion. Are they in proportion means do they have the same ratio or not? Okay, so is equal. So that is 2 by what? 4. Now both of them get cancelled. What will it be? 1 by 2. This is the first thing. Now let's talk about the second thing. Largest side of triangle ABC. What is the largest side of triangle ABC? AC. Okay. Let's look out for triangle PQR. Which is the largest side? PQ. So we write as PQ. Then next thing. What is the value for AC? 3. So we'll write 3. What is the value for PQ? We'll write 6. Okay. Now let's substitute, like let's simplify. So what you will get? Again 1 by 2. This is the second thing which you get. Now let's go to the last side. So that is BC. Okay, and PR. So for BC the value is 2.5. So we'll write 2.5. What is the value for PR? 5. So we'll write 5. Both of them get cancelled. Okay, how this cancellation got? I'll explain you this part. So if it is 2.5, Okay, and it is 50. So if you multiply the decimal of 2.5, so this becomes 25. If we remove by 2 times is considered to be 1 by 2 is the okay. 1 by 2. In triangle ABC and triangle PQR, you can see that the first size we got the ratio as 1 by 2. In the second, also we got the ratio as 1 by 2. In the third, also we got the ratio as 1 by 2. That means that AB upon QR is equal to AC upon PR is equal to BC by PR. That means all of these three sides are in proportion. Now, what does that mean? That means that the given like that means the given triangles of what? Triangle ABC is similar to triangle Q. Now, how will you write this? I'll tell you this part first. Okay, so this they have given as AB. According to the corresponding, so like AB is what? AB corresponds to QR. So in case of AB, your AB corresponds to which triangle? AB corresponds to QR. So you can see in this part, I've highlighted it. Okay, so we'll write Q and then B corresponds to what? B corresponds to R and C corresponds to P. So whatever angle they are corresponding, according to that only you have to name the triangle. Okay, so triangle ABC is what? Triangle ABC is similar to, now first we have written Q. Why Q? Because Q corresponds to A. Now B corresponds to R and C corresponds to P. So therefore, triangle ABC is similar to triangle QRP by SSS criterion. Okay, so I hope you're clear with all the three tests of similarity. So this was the second part of our session, and let's jump into the third, that is the hashtag 3 of our session. Okay, so in this part, we'll be studying areas of similar triangles. Now, this is a theorem. Now, this is this theorem explained. Before that, let's check what and how we calculate the triangles. Formula for the area of triangle is half into base into height. So first let's check out this triangle. So this is triangle A with altitude as AB and triangle AFE is the triangle. Okay, so what is the area of triangle? It is half into base into height. So if you check for this triangle, what is the, if you check for this triangle, what is the base in this case? Base is FE. What is the base? Base is the FE part. Okay. And what is the height in this case? Height is AB. Okay. So what will be the, like if you want to calculate the area of this triangle, the base and height, it will be half into what? FE into that is half into FE into AB. This is how you calculate area of a triangle. So what, like if you have to calculate any simple area of a triangle, so what is the formula? It is half into base into height. So But on the basis of this formula, now this formula is important because on the basis of this formula, we'll be studying the next part of the session, that is the C part, areas of similar triangles. Okay, now what does areas of similar triangles mean? This is a theorem which explains that the ratio of areas of triangle to the square of ratio of the corresponding side. Now, what does that mean? That now if we have triangle ABC and we have triangle PQR, so whatever area will be to prove, what we have to prove in this part is area of triangle ABC by area of triangle PQR. So what is that? That is ratios of areas of, that is what? That is what ratios of areas of similar triangles. Okay. Now next thing what we have is equal to square of ratio of their corresponding side. Now you know A corresponds to Q, corresponds to Q, yeah, correct? So now what are they telling? That ratios of areas is equal to squares of the ratio of the corresponding side. So each of the corresponding side. Okay, let's check this out, how you can do this. So next let's look out for the proof part. Okay, so we have triangle ABC and we have triangle PQR. First is for finding the areas of the two triangles, we draw altitudes AM and PM. So what are altitudes? Altitudes are the heights. Okay, so as you know, I just told you in the previous thing that we need height and the base. If we talk about this triangle, they already have ABC, but we drew these dotted lines as a ABC. For triangle ABC, AM is the altitude, and triangle PM, triangle PQR, PM is the altitude. Now, triangle ABC is equal to half. What the how you find the area of a triangle? Now, area of triangle PQR is equal to half into QR into PM. So QR is the base and PM is the height. So what we'll do is we'll write area of triangle AC upon area of triangle PQR is equal to whatever the values we got from the first. And you can see that we can cancel out both of these halves. Correct. So get area of triangle ABC into AM. Is it what we want? Yet we are not done yet. Okay, so let's move towards the next part. So ABM is equal to triangle PQN. So let's look out for ABM. This is what the triangle is. Triangle ABM. Now this is the part we are talking about. Okay, this triangle and PQN, this triangle. Okay, now let's. You can see that this angle corresponds to angle Q, so angle B is equal to angle Q. Okay. As triangle ABC is similar to PQR, so they have already given us that both of these triangles are similar. This theorem is if the triangles are similar. If they are not similar, you cannot prove that areas of similar triangles. Okay, so this is for areas of similar triangles. Next is angle M is equal to angle N. So you can see that both of these angles are height of the triangle. You can see that both of these are height of the triangle, so therefore they'll be what? They'll be 90 degrees. Okay, and both of these triangles are similar by which test? AA test. So you saw in my previous hashtag two part that what is AA similarity? That is angle. So if two angles are congruent, then they are considered to be what? The triangles are similar. Now let's move towards the next part. So if you talk about angle ABC is similar to PQR, which is already given to us. Okay. Now, so as we are similar, we'll write all the ratios. So area of triangle ABC by area of triangle PQR is equal to AB by PQ into AM. This part. Okay, so area of triangle ABC by area of triangle PQR is equal to AB by PQ into AM by PN. Now AB by PQ is equal to AB by PQ. So what we are doing is whatever we have, like you see that AB and PQ are AB by PQ is equal to BC by QR. Correct? So here we have BC by QR. So in place of that, we'll write AB by PQ. Okay, and AM by PN, we have written it as it is. We have written it as it is. Okay, so PN is equal to, because both of those, like as BC by QR is equal to AB by PQ, then it is equal to AM by PN as well. Okay, this will become AB by PQ and this will be AB by PQ the whole square. Okay, so from this you get the answer, that is what you had to prove, that is what uh, that is the ratio of areas of two similar triangles is equal to the ratios of their corresponding sides. So whenever we have two triangles which are similar, then the a square of the ratio of the corresponding sides. Okay, but you can see that they are squares. Okay, let's move towards the question for this topic. So we have triangle ABC is similar to triangle DEF. Their areas be respectively. So they have already given us the areas. Okay. So 64 centimeter square and 121 centimeter square. If EF is equal to 15.1, 15.4 centimeter, find BC. So they have given us area and they have told us to find out, and they have told us to find out the answer, that is the value for B. Okay, so for triangle ABC is similar to DEF, which they have already given us. Then area of triangle ABC by area of triangle DEF is equal to BC square by EF square. Okay, now how did we get this? This is the ratios of areas of two similar triangles equal to the ratio of squares of the corresponding sides. So this is the theorem we just learned. Okay, so now what happens is theorems are they are the proof to some topic, like they are proof to a part of the topic, and by the proof of those theorems we'll be solving the sums on that. Okay, so in place of area of triangle ABC we'll put 64, and in place of area of triangle DEF we'll put 121. So this will, in the place of BC it will be nothing because we don't have the value, and in place of EF it will be 15.4 the whole square. So 64 by 121 the whole square. What we have done is we have taken square root on both the sides. What is the square root of 64? It's 8, and for 121 it is 11. Now we'll cross multiply the whole thing and we'll get the answer as 1.2 centimeter. Okay, so this is how you have to apply the theorem in your questions. Okay, so here we are done with the whole part of the session for today. Let's have a quick summary of today's session and then we'll end with this. So first we studied what are triangles. Triangles are shapes with three angles and sides. Two figures having the same shape and not necessarily the same size are called similar figures. Two polygons of the same number of sides are similar if corresponding angles are equal and corresponding sides are in proportion. And if we talk about two triangles, so two triangles are what? Two triangles are considered to be similar if their angles are equal and the sides are in proportion. We can prove triangles can be similar by three tests, that is AAA or AA test, or SSS test, SAS test. Okay. Area of triangle is equal to half into base into height. So the last theorem was the ratio of areas of two similar triangles is equal to the square of the ratio of their corresponding sides. Okay. So So here we are done with the session. So thank you so much for being here for the webinar, and I hope you understood the whole part and enjoyed this session. Do now join us for further classes, webinars, and group classes at Learn Tech. And thank you so much for being here. And bye for today. Have a nice day and stay home, stay safe. Bye bye.